Hello guys, very welcome to my YouTube channel. My name is Shambhunath Mishra and today I am going to do a little unique video which I have not done earlier on this channel, but I am really excited to do it because it includes a live demo as well. So I have this switch, Cisco 3550 switch, which I bought long back from eBay, and I bought it for my CCNP studies at that time, and then I used it for quite some time, and then I have just put it somewhere at my home in the storage, and I never used it after that. So for I think 5 years it was sitting there. So recently I discovered that, and I pulled it out, and I thought I'll start using that particular switch in my upcoming videos. So that is what I'm going to do. I'm going to do a simple, very basic concept in computer networking, which is called layer 2 network loops. So whenever you start, if you're a beginner in CCNA or if you're a beginner in computer networking world, this is the thing which you will start learning about after completion of your very basic thing, like what is the IP address, how a network looks like, and all those things. Once you get those nomenclatures, you will start your L2 journey with network loops and something which is called spanning tree, well-known spanning tree, everybody knows it. In this particular video, I'll give you a small glimpse of the theory of network loop, and then I'll give you a real life demo that how a network loop actually looks like. First of all, let me go through the theory. With the help of this slide, I'll explain you a little theory about network loop. Here we have three switches: switch 1, switch 2, and switch 3. And these MAC address tables which you see here are just for symbolic purpose. It doesn't give the actual MAC address table content of these switches. So this is just for symbolic purpose, just to give a little pictorial representation for my explanation. So normally what we know is switches does forwarding on the basis of MAC address table. This is also called content accessible memory, or CAM table, where we will have the source MAC address and the port over which it is learned. So whenever any packet comes to the switch, it will see the MAC address table that the destination of that particular packet, that is destination MAC of that particular packet, over which port of the switch that is learned. So if the destination, for example, packet A reaches to switch 1, and it has destination MAC as AAA and BBBB CCC1, which is learned over fast Ethernet 0x1. So switch knows that I need to forward this particular packet over the fast Ethernet 0x1 interface. So that is how the CAM table or MAC address table is referred for all kind of layer 2 forwardings. So this is the network where I'm going to explain that how loop forms, and for that you need to consider that the spanning tree is not running here right now, correct? Because if the spanning tree is running, there would not be any loop at all, because if the spanning tree is running, the redundant path would be in blocking state. For example, here between switch 1, switch 2, and switch 3, we have 3 links connected. So maybe if the spanning tree is running, this particular link would go in blocking state. Any of the link can go in blocking state, but for our explanation purpose, let's assume that this link would go in blocking state, and there would not be any redundant path. So here I have mentioned 3 reasons which are mandatory to form a loop. For the first reason is there must be a redundant path. If there is no redundant path, there won't be any layer 2 loop in that case, because there should be a redundancy to loop the packet back to the origin switch. The packet should be broadcast or multicast. So this deserves a little explanation, because why the packet needs to be a broadcast and multicast, because this needs to create a storm in order to affect the network or the switches in true manner. So if you say that there is a layer 2 loop and a single packet is looping between all 3 switches, It is not going to cause any harm to these switches. These are very powerful switches, and a single packet looping indefinite time would not cause any problem to these devices. So probably this can cause the problem with that particular flow for which the packet is belonging, but in general the switches CPU would remain low, there would not be any packet drop, etc. Those things would not be observed. So we need a replication. So in broadcast or multicast packet, what happens is whenever switch receives the broadcast, it forwards the replicates the broadcast to all of the other ports which are belonging to the same VLAN, right? So that adds the replication part of it. The longer the loop persists, the number of replication would increase, which will eventually cause the bigger storm, and that storm will keep on increasing if you do not contain it on time. So that causes the real problem. The third part which I have written here is infinite TTL. So we know that TTL value is not present in layer 2 frame, right? It is the layer 3 field. It resides in IP packet, and there would not be any TTL value sitting in the layer 2 frame. So packets like ARP, they won't have any TTL value, and no matter how many switches or how many routers for how many iterations they're crossing, it would not eventually get dropped because they're due to TTL, because there is no TTL field at all in those frames. So these are the three important factors which needs to be present in order to cause a loop in a network. So in this network, for example, let's take an example of PC. This sends a broadcast to switch 1. Now we are assuming that this particular network doesn't run spanning tree. So all these interfaces are in forwarding state. None of them are in blocking state. So the packet would reach, first of all, the packet would reach to switch 1. Switch 1 sees that it is broadcast, so it would not forward it to the port where it has received it, but other ports which are part of the same VLAN over which it is received, it would start forwarding it. So for example, it is received here, so it would not forward back the packet over this particular link, but it will forward the packet over this and this link. So there is a replication. It has multiplied the packet by 2 and sent it. One instance is sent here, another instance is sent here, right? So one instance goes to switch 2, another instance goes to switch 3. So for example, for now we'll focus on the instance which went to switch 2. What switch 2 would do, it will also it will also look at the packet destination. It sees that it is a broadcast. What I do in cases of broadcast, I'll just forward it to all the interfaces belonging to the same VLAN. So it has just one interface. It is received on this particular interface, but so it won't forward it back to this interface. Then remains just one interface where the packet would be forwarded. Hence the packet reaches switch 3. Now switch 3 also does the same thing. It would not forward the packet here, it would forward the packet here. Now this time the port is not blocked, so because spanning tree is not running, so the packet reaches switch 1. So this whole path is a loop because the packet is coming back to switch 1. It was originated from switch 1, it is coming back to switch 1. So it will cause one anti-clockwise loop in the network. Similarly, if we think of the another flow, like here we had two packets, right? One packet went this side, other packet went this side. Similarly, if we consider the second flow where the packet went to switch 3, it will also keep on forwarding on the port, forwarding the packet on the port where the packet is, where the broadcast packet is not received, and eventually this will also cause the loop in clockwise direction in this network. So this single packet has caused two kind of loop in this particular network. One is clockwise, one is anti-clockwise. To prevent these cases, we need spanning tree or any of such kind of protocol to avoid the loop in this particular situation. So this was the basic theory related with the layer 2 loops. Now with this, I'll just move to the real life demo. So what I have is I have a 3550 switch like this, and what I'm going to do is I'm going to connect two ports of the same switch with a single Ethernet cable, which will create a loop between these two ports on the switch. Long back, when I was starting my journey with the networking world, somebody told me you can kill the switch by just doing that. But let's see if it happens here or not. We'll hop on to the real life demo and we'll see if that was true at all. Okay, and eventually we'll create a loop on that particular switch, and we'll try to figure out that what are the possible ways to mitigate the switch, and we'll also see that what happens to a switch when the loop is created. Okay, guys, so this is my switch. If I do show version, this is very old switch, 3550 switch, and running some 12.2 version which Cisco had. And if you want to download this particular image from Cisco website now, you won't even get it. So this is very basic, very old switch, which I still have. So but it is good, if you want to practice some very basic CCNA and some CCNP level concepts. So this still works. So that is why it is not, I'm not saying it is totally unworthy to have it. This is very powerful switch even now. So let's get started. You can see in the video that I have this switch running. All the LEDs etc. are up, and now what I'm going to do first is I'm going to connect two ports. I have these two interfaces, Fast Ethernet 0x5 and Fast Ethernet 0x6, which I'm going to connect in a loop with the help of Ethernet cable. And our intention is to see what exactly happens if I do that. So let's first of all check the configuration. Show run interface Fast Ethernet 0x5. Okay, show run interface Fast Ethernet 0x6. So if you see, these interfaces are in Vlan, are part of Vlan 1 currently. So let's get started. Let's pick a Ethernet cable and connect these ports. Alright, you must be noticing that the ports are in amber state now and they are blinking. Here in the console we see that ports status has come up. So let's see for how much time, maybe for around 52 seconds it will remain in the amber state, and then after that the state would change in green, and still one of the port is in amber state. So I really don't think that it is going to cause a loop, because in my view STP has triggered and it has blocked the port. So let's see, show spanning tree VLAN 1 if we do. Okay, sure enough. So we see that 0x5 is designated forwarding port, and 0x6 is a blocking port. So this is totally a myth that if you loop two ports on a switch with a single Ethernet cable, it will cause a loop. It won't cause a loop as long as we have this STP running on the switch. So the STP is there to prevent any redundant path, even if it is done on a single switch with the help of an Ethernet cable. Great. So now I'm going to do the next experiment. What I'm going to do is I'm going to disable spanning tree on the VLAN 1. Let's see what happens. Since we have a redundant path, for now STP is saving us. Let's see if we don't have STP, what happens to those ports. Conf spanning tree VLAN 1. Look at the video of the switch now. So what we see that both the ports are in forwarding state now. The amber LED has gone. port is in up condition now. If you do show spanning tree VLAN 1, it says that there is no spanning tree instance running for the VLAN 1, which is right. So in this case, the spanning tree is disabled and two ports are connected in a loop on this particular switch, but still we do not see any loop, isn't it? If the loop is happening, first and foremost thing what you will observe on these ports is they'll start blinking at a very speed manner. So you'll see, by looking at the switch itself, you would know that there is something wrong. I mean, this cannot be the normal data. You know, the fashion it blinks, you should be able to tell that it is something going on. There is a huge data coming on these interfaces, or there is a loop existing in the network. So you would know that a switch is going mad with the data. But for now, if you see at the video, the LED is solid green, which actually tells that there is no data on this on the port currently. So what I'm going to do is I'm going to put some data on this port. So I'm going to connect a PC to one of the ports. Let's say 0 by, let me see, show VLAN. In VLAN 1 I have 0 by 6. I'll connect a PC on fast Ethernet 0 by 18. Let's see what happens, because as soon as I insert a PC, as soon as I connect a PC to any of the port of the switch in the same VLAN, the switch will start receiving broadcast, I mean basically ARP from that particular PC. So that ARP is a broadcast, and since it is a broadcast, it should get forwarded to all the available all the ports which are residing in the same VLAN. So let's see, I'm going to connect it for now, and let's see what happens after that. Okay, so I'm going to connect a PC on fast Ethernet 0 by 18. Okay, so you see that this PC is connected on fast Ethernet 0 by 18. Now the port has come up, it is green, and if you look closely, the LEDs on port 5 and port 6 also blinking insanely. So it looks like there is a huge traffic coming over that port, and looks like we have achieved something called layer 2 loop on this particular switch. So I'll just quickly check the CPU utilization on this particular switch. So show process CPU sorted. You can see that it is running 99% CPU currently, and 73% is just by the interrupt. That means it is receiving huge amount of packet, and also the highest amount of CPU cycles is taken by ARP input process. That means the ARP is causing the issue on this particular switch. Show process CPU history. If you do, you can see that the CPU is overloaded. Now let's see that how we can mitigate it. I mean, we know that there are a lot of technology. We know the spanning trees exist, and there are many other technologies exist, but if we don't have spanning tree, what else we can do? So my favorite is storm control. What I do with this storm control is, in all the switches whatever you have in your environment, you must have storm control to save your switch from the huge amount of broadcast or the multicast traffic. So you can also do this whenever you, for example, you are seeing a network loop in your layer 2 environment, but you are not able to figure out that where exactly it is and how to mitigate it. Then first and foremost thing you can do is apply storm control on all of the interfaces as quickly as possible. So it will at least save you some time and give you some time to try and figure out the network loop. So here I'm going to implement storm control on, uh, sorry, not on fast Ethernet 0 by 1 because that is not my interface. I'll go in fast Ethernet 0 by 5, storm control for broadcast, and the level packet per second I want just 50. And similarly, I'll do for the multicast. Storm control multicast level packet per second is 50. I don't want more than 50 50 broadcast or multicast hitting my interface at any given point of time. Similarly, I am going to do this on fast Ethernet 0 by 6. Storm control broadcast level packet per second is 50. Storm control multicast level packet per second is 50 again. So you can look at the switch right now. We see that the high amount of traffic is stopped. We can tell this by looking at the switch port itself, because the ports are now solid green and it is not blinking insanely now. So it looks like the broadcast storm has stopped. Now if you want to confirm it, you can do show process CPU sorted. Alright, sure enough, you can see that right now the CPU utilization on this switch is dropped. Looking at the CPU utilization right now, we can say that although we are not able to mitigate the loop, but we were able to save our switch. So in this window, whatever you have got after applying the storm control, you can actually log into to the switch and try to figure out in logs that which ports might be having issues which is causing loop in the network. So storm control gives you that particular window. It all, even though the loop is existing right now on this particular switch, but still you get the window to do some kind of troubleshooting. So it is a very important feature you should always have in your network. So with this, I think I'm good with the demo. I'll just let me move to the key takeaways now. So we have discussed that there must be a redundant path to form a loop first. There should be a multicast or broadcast traffic coming into the network. That is how we have connected the laptop in fast Ethernet 0 by 18 port, and that has started sending the broadcast which has created the loop in the network. So that point 2 is also mandatory. There should be some traffic which has the infinite TTL value, so that no matter how many times it is looping in the network, it is not never going to die down. So that should be there. And yeah, we have found out that looping a particular Ethernet cable to the same switch, it won't cause any loop, because STP is active on the switch and it will block one side of the port. Always have storm control in your layer 2 network, always. All right, thank you so much for watching the video. If you have not already, please subscribe to the YouTube channel. I am going to give more demos like this very soon on this channel. Thanks so much. Have a nice day ahead.